So this part of the last part here will just be dealing with these three questions on the last page. So the first one, it says determine the vector and parametric equations of the plane parallel to the YZ plane and containing the point P511. Now this we have to go back a little bit and think about our planes for a second. Just grab all these while I'm here. And what does it mean? What does the YZ plane mean? You need to know what that is. Okay. So parallel to the YZ plane, if you can think back to what that meant no X direction allowed. So, think when I was describing this to you the first time, I said the board is a good example of the YZ plane because the board, you're not allowed to move forward or backward. Of course, on the board you can move left, right, up, or down, but you can't move forward or backward. So there's no X direction allowed. And when we say that, we mean no X movement is allowed. So let's just think about how that actually makes this question extremely straightforward. A plane, recall, is defined as a point plus a vector plus t times a vector plus s times another vector, right? And the two vectors m1 cannot be equal to k times m2. Okay, so what we need is we need two vectors that would be on the YZ plane, right? And we need a point. So the point is given to us. It has to contain the point 511. And then we need two vectors that are only on the YZ plane. Now, the YZ plane does not allow movement in the X direction. So here's a vector that's on the YZ plane, 0, 4, 3. I can put whatever numbers I want for y and z, right? As long as I don't put an x. I'll make it even easier for myself. Let's make it 0, 0, 1. Then I can make the second vector 0, 1, 0. And now I have two vectors that are parallel to the YZ plane. They move in the y direction or the z direction, but they don't move in the x direction. What this will do is it will create the equation of a plane that has the properties I want. So let's quickly just start a new one here and we draw this again. So the YZ plane corresponds to the equation x equals 0. Here's the YZ plane. So if we were looking straight at it, the way you're looking at the board, it would look like this, right? You can go left and right, you can go up and down, but you can't go forward and back. There's no forward and back allowed. Okay, now we need this equation, but we need it to pass through this point here, 511, and you can see right now it clearly doesn't. So what we do is we make up two vectors that we know are parallel to the plane. Any two vectors will work as long as they have an x of 0 and they are not collinear with each other. Let's do the simple example first. So m1 is equal to 0, 1, 0. Okay, m2 is equal to 0, 0, 1. And then I'm going to go plane, starting at point A using directions m1 and m2. And you can see it's perfectly parallel to the one I want, but it passes through the point I want. Now what if I didn't know to make the vectors 0, 1, 0 and 0, 0, 1? What if I made them up? What if I said 0, 8, 7 and 0, and I made the other one here 0. Okay, it's twice now I've tried to make it equal to pi and it's ending up pausing my recording, so let's just make it 3.14159 and negative 10. And it does not make any difference to the plane that's getting constructed because these two vectors are not collinear and they both have an x coordinate of 0. Notice if I make the x coordinate a 1, now my plane's screwed up. It's not parallel to my other plane anymore, and if I just zoom out far enough, you'll see that these two planes are going to cross and are in fact not parallel. Right? They're making like an A sort of shape. It's hard to appreciate that, but it'll make it easier if we make this 10. Okay, you can see these two planes cross and are no longer parallel. I've ruined that because I let them move in the x direction. I don't want to let them move in the x direction, and as long as they're not moving in the x direction, my two planes will remain parallel. Okay, so to create something parallel to the YZ plane, you have to remember the YZ plane means no X movement. So the two vectors I chose need to have 0 in the X in terms of their direction. Okay, let's move on. The second to last says determine if the point P lies on the plane. Now, creating the equation is easy. You have lots of latitude. Solving if a point is on the plane, that's not so easy. What we need to do here is we need to express the idea that this point can be found using those two vectors. So the best way to do this is to do the parametric equations. Let's get the parametric equations for our plane. 4s plus 2t would be 4x, right? For y, I start at 1. I have 1s and 1t. And for z, I have 1 plus 3s minus 1t. Okay? To check if a point is on a plane, what I need to do is I need to set up a system of equations and check if I can get a consistent pair of s and t parameters. So let's do our first equation. -6, which is the x coordinate, is equal to 1 plus 4s plus 2t. Okay, I'm going to isolate for, so let's say just first set the x parametric equation to the x value of your point. Okay, once that's true, so I did that here, and then what we're going to do is isolate s or t. So we're going to go bring the -1 over. We get -7 is 4s plus 2t. We get -7 minus 4s equals 2t. And therefore -3.5 minus 2s equals t. Okay, so I know I've got an equation for t there. I'm going to then set the y parametric equation to the y value of your point. We have the y value of my point is 2. So 2 equals 1 plus 1s plus 1t, right? That's the y of the point and then the y of the parametric equation. I'm going to replace the t with the substitution from my x parameter. So what I mean here is I'm just talking about this equation here. And so we're going to go 2 is equal to 1 plus 1s plus 1 times this parameter, 2s, right? So I just stuck that in instead of t. What this now lets me do is create an equation, 2 equals 1 plus s minus 3.5 minus 2s. And I can generate the equation 4.5 equals -1s. And thus -4.5 is equal to s. Okay, and a quick check of that. Let me just go back and check and make sure this works. So we go 2 equals 1 minus 4.5 is -3.5. Minus 3.5 is -7. Take away 2 times -4.5 is +9, which adds to -7 to make 2. So this is good. So I solved the equation for s. Use s to solve for t. Okay, so we know that -3.5 minus 2s equals t. So we go -3.5 minus 2 times -4.5 equals t. -3.5 plus 9 equals t. And therefore t is equal to 5.5. Okay, so we know that t is 5.5 and s is -4.5. Like we did with lines, we are going to use the z equation to check. Okay, the z equation is just back up here. Just make a new page with this one. And I know the z of the point I'm looking for is the number 3. So 3 is equal to 1 plus 3s minus 1t, keeping in mind that t is 5.5 and s is -4.5. So here we get 3 equals 1 plus 3 -4.5 minus 1 5.5, which tells me 3 is equal to 1 minus 13.5, minus 5.5, and 3 is equal to negative 18, which is false. So therefore, the point is not on the plane. Again, let's take a quick second to check and make sure that that's correct. So I'm going to just have it draw this plane for us. So new. So remember, to draw a plane, I need a point, which is 1, 1, 1. I need a direction vector, which is 4, 1, 3. I need a second direction vector, which is 2, 1, minus 1. And then I can say plane A, M1, M2. It draws a plane. Okay, it draws a plane that's parallel to those two vectors and contains point A. Now when I draw point B, point P, negative 6, 2, 3, you can see very clearly P is nowhere near that plane. Right? There's a good chunk of distance between the two of them. And that is why our equation failed to yield something that made sense. Now, the last equation here, the last question, we're given a plane and we're asked to determine the point of intersection between pi and the z-axis. Now, what do we know about the z-axis? The z-axis contains all the points of the form 0x movement, 0y movement, z. So if you have an intercept in 3D, an intercept means the other two components are 0. So just quickly, an x-intercept would be of the form x, 0, 0. A y-intercept would be of the form 0, y, 0. And a z-intercept would be of the form 0, 0, z. Thus, our plane, right, if you think about the parametric equations for our plane, we have to make x and y equal 0, and then we have to figure out whatever z is. So to do that, again, we're going to get the parametric equations and set them equal. So we're going to go 0 for x equals 6 plus s plus 2t. Okay, do you see how I'm doing this? I know x has to be 0, so I'm setting x equal to the parameters that define that. And this gives me the equation s is equal to negative 6 minus 2t, right? Just isolate for s. Now, I use the same thing to talk about y. Okay, 0 for y, I know it has to be 0 because we're talking about a z-intercept, equals the parametric equation, negative 2 plus 3s plus 2t. I know that what s is equal to, because I isolated it in x already, plus 3, negative 6 minus 2t, plus 2t, plus 2t, right? So I'm just writing out this equation again, except I'm replacing s with what I know it to be equal to. And then I see 0 is equal to negative 2, minus 18, minus 6t plus 2t. And this tells me that I got negative 20, so 20 equals negative 4t, and therefore t is equal to negative 5. I remember that s is equal to negative 6, take away 2 times negative 5, which is s is equal to positive 4. So when s is positive 4 and t is negative 5, we get the coordinates where x and y are both 0. To determine the location of z at that point, we're just going to give our equation for z. The parametric equation for z here was I start at the coordinate negative 3 plus 0s minus 1t. To solve this is easy enough. Z equals negative 3, take away 1 times negative 5, z equals 2. So I should have a z-intercept. So the z-intercept is 0, 0, 2. To check this, again, we can quickly draw this one. 6, negative 2, 3 is my point. 6, negative 2, 3. One direction vector is 1, 3, 0. So 1, 3, 0. The other direction vector is 2, 2, minus 1. 2, 2, minus 1. Okay, and I'm looking for where this contacts the z-axis. 6, negative 2. Sorry, not positive 3, negative 3. There's a mistake there. And you can see if I draw that point on the z-axis at 0, 0, 2, that point is the z-intercept of my plane. Okay,